In 499 AD, the Earth's axial tilt was 23.42 degrees. An ancient Indian text dated to that exact year states it was 24. That is not a rounding error. It is not an approximation. 24 degrees was the tilt around 12,000 BC, and again around 3000 BC. The text is the Aryabhatiya, and that is only the first of 3 measurements it gets wrong, all in the same direction, all pointing to epochs tens of thousands of years before its supposed date of composition. The first measurement is obliquity, the angle at which the Earth's axis tilts relative to its orbit around the Sun. This tilt is what gives us seasons, and it is not constant. It oscillates slowly over a 41,000-year cycle, swinging between roughly 22.1 degrees and 24.5 degrees. The change is small, about 1/100th of a degree per century, but it is relentless, and it is precisely calculable. We can determine the exact obliquity of the Earth at any point in the past using models developed by Jacques Lascar and the Paris Observatory. Aryabhata states the obliquity of the Earth as 24 degrees. In 499 AD, the actual obliquity was approximately 23.42 degrees. That is a significant discrepancy for a text renowned for its mathematical precision. Aryabhata was not rounding. His entire system of spherical trigonometry depends on this value. Every calculation of declination, latitude, and eclipse prediction in the Aryabhatiya is anchored to this number. 24 degrees was the actual obliquity of the Earth around 12,000 BC, and again around 3000 BC. Researcher Nilesh Oak and astronomer Rupa Bhatti presented detailed corroboration for the 12,000 BC epoch at Oxford University in 2018, cross-referencing the Aryabhatiya's obliquity value with pole star positions and apsidal alignments from the Surya Siddhanta, another ancient Indian astronomical text. Multiple independent astronomical parameters converged on the same date. But that is only the first measurement. The second is more specific. The Aryabhatiya defines the city of Ujjain as the reference point for the sun's northernmost declination. In Golapada verse 14, Aryabhata states that Ujjain lies exactly 22.5 degrees north of Lanka, his equatorial reference point on the same meridian. This is not simply a statement of geography. If Ujjain marks the sun's northernmost point, then the number Aryabhata assigns to Ujjain's latitude is also a statement about the obliquity of the Earth at the time of observation. The sun's northernmost declination equals the obliquity. If the sun turns north at 22.5 degrees, then the Earth's axial tilt was 22.5 degrees when that observation was recorded. The Earth's obliquity last equaled 22.5 degrees approximately 25,000 years ago, around 23,000 BC, not 499 AD, not 3000 BC, not 12,000 BC, 23,000 years before the present era. This is not interpretation. This is a calculation anyone can verify. The Lascar obliquity models are published, peer-reviewed, and publicly available. The verse is in the critical edition of the Aryabhatiya. The arithmetic is straightforward. Now here is where it becomes extraordinary. Because the Aryabhatiya contains a third measurement that should be completely unrelated to astronomy, and it points to the same deep epoch. In Golapada verse 12, Aryabhata describes the positions of the Earth's north and south poles. He states that Meru, the north pole, is at the center of the land, and Badavamukha, the south pole, is at the center of the water. Today, this description is inverted. The Arctic is an ocean surrounded by continents. Antarctica is a continent surrounded by ocean. If Aryabhata were describing the modern Earth, he got it exactly backwards. For a text that accurately describes the Earth as a rotating sphere, that calculates planetary periods, that predicts eclipses, getting the poles backwards would be an inexplicable error, unless he was not describing the modern Earth. In 1958, Charles Hapgood, a professor at Springfield College in Massachusetts, published a theory of Earth crust displacement. Albert Einstein wrote the foreword to his book. Hapgood proposed that the Earth's outer crust could shift as a unit over the mantle, relocating the geographic poles to entirely different positions. His 1970 book, The Path of the Pole, mapped these proposed positions using glacial evidence, radiocarbon dating, and paleomagnetic data. According to Hapgood's research, between approximately 55,000 and 12,000 years ago, the Earth's north geographic pole was located not in the Arctic Ocean, but over the Hudson Bay region of Canada. The coordinates he calculated were approximately 60 degrees north, 83 degrees west. That is, the Canadian Shield, continental crust, land. The antipodal South Pole during this same period would have been located at approximately 60 degrees south, 97 degrees east. That is, the southern Indian Ocean, open water. North Pole on land, South Pole in water. That is exactly what Aryabhata wrote. The Hudson Bay region is continental crust that was buried under 3 to 4 kilometers of ice during the last glacial period. The modern bay exists because the land was depressed by the weight of the Laurentide ice sheet and has not fully rebounded even today. It is still rising at 8 to 12 millimeters per year. Before and during the Ice Age, this was land, not water. 3 measurements from a single text. The obliquity value of 24 degrees, placing its origin no later than 12,000 BC. The Ujjain latitude of 22.5 degrees, placing a specific observation at approximately 23,000 BC, and a description of pole positions that matches the geological configuration of the Earth between 55,000 and 12,000 years ago, a configuration that has not existed since. 3 independent data points, astronomy, geography, and geology, converging on the same epoch. The mainstream date of 499 AD was not derived from the content of the text. It was derived from a calculation of elapsed years since a assumed Kali Yuga epoch of 3102 BC. Nilesh Oak has demonstrated in separate research that this 3102 BC date is itself the product of circular reasoning, where the date of the Kali Yuga was calculated from the Aryabhatiya, and the Aryabhatiya was then dated based on the Kali Yuga. The text was used to date the era, and the era was used to date the text. None of this proves that Aryabhata personally observed the sky in 23,000 BC. What it suggests is that the Aryabhatiya is a layered text, a document that preserves astronomical and geographical data from vastly different epochs, compiled and transmitted across millennia, with later authors adding to and updating a framework whose deepest layers encode observations far older than mainstream scholarship acknowledges. This is not unprecedented. The Surya Siddhanta shows the same pattern. Oak and Bhatti identified astronomical parameters within it that converge on 12,000 BC, including pole star positions and seasonal alignments that only work at that specific epoch. Ancient Indian astronomical tradition appears to have functioned as a living repository, carrying forward data from earlier periods while updating computational methods for contemporary use. The Aryabhatiya describes a rotating Earth. It calculates the circumference of the Earth to within 1% of the modern value. It provides a value of pi accurate to 4 decimal places. The sophistication is not in question. What is in question is whether a text this precise would record the wrong obliquity, the wrong latitude, and the wrong pole positions for its own supposed era, while accidentally recording the correct values for an era 25,000 years earlier. 3 errors that all point to the same date is not error, it is evidence. The verses are in the critical edition. The obliquity models are published. The geology is documented. The arithmetic is open to anyone. The Aryabhatiya has been waiting 25,000 years for someone to check.